Alpha, is your mic working?
Yes, it's working. Are you hearing me?
And now we are hearing you.
Okay. So the problem was my earphones. Okay, thank you.
Okay.
Good evening, guys. Good evening, sir, Mr. Jimana. My name is Alpha. I'm going to present on behalf of Group 1 on Java classes and objects. Just allow me to share my screen. Let me share the end screen. It's a Word document. Can you confirm if you are now seeing my screen?
As of me, yes.
Okay.
What about others?
Yes, we are seeing a screen.
So you can proceed now.
Okay, thank you. So, as I said earlier, I'm going to present on.
So Alpha, there's a hand by Thomas.
Okay, can you go ahead, Thomas?
You are on mute, Thomas. Yeah. It's okay. You can proceed. I think if you've got something to tell us, he will do so by the chat.
Okay, thank you. So, as I said earlier, I'm going to present on classes and objects in Java. I'm not going to talk much on these things. This is the overview. The topics we are going to discuss in this presentation. We're going to look at the introduction on classes and objects, and also we are going to talk on the definition of class, and also on object creation, and how do we access member of a class, and then we will jump to the conclusion of the presentation. This is a lineup of our introduction. Firstly, we'll be looking on, we'll be explaining on what is object-oriented programming and why is it useful. And our number 2, we will be defining the terms, class, objects, attributes, and methods, and also constructors and instances in Java. And number 3 on introduction, we'll be looking on examples of a class and an object in real life. So what is object-oriented programming? Object-oriented programming is just a term we use when referring to a programming practice where we use objects and classes. So in object-oriented programming, we use classes which may contain data and codes and objects, just like that. Object-oriented is useful because it allows programmers to structure a software program into simple, reusable pieces of code, which are called classes. Okay, so in other ways, we can say object-oriented makes it easier to modularize our code, to make our code in small pieces, which we can use over and over again. And also object-oriented programming supports most important concepts such as inheritance, polymorphism, abstraction, and encapsulation. And also it makes the code more modular, as I said earlier. It also makes the code more extensible and maintainable. This just means we can easily maintain our code when it is modular. Let me just give you an example of a human being. A human being is consisted of modular pieces, like you've got a left hand, a right hand, a right leg, a left leg. You've got an ear. You've got the head as a whole. So it's easy to know if the pain is on the ear. So that's how it is like when you are programming in object-oriented programming. Okay, so let's turn over to the definition of terms. What is
before that, sorry to interrupt. Can we make sure that our microphone are on mute as well as our camera are actually turned off?
Okay.
Primrose Mutandwa, can you please switch off your camera? You can,
guys with,
yeah, you can proceed.
Okay, thank you, sir. So we are now on the definition of terms. Firstly, we'd like to talk about what is a class. A class is a blueprint or a template that defines a common attribute of and methods of a certain type of object. For example, we can have a class called animal that defines the attributes, such as the name, age, and weight of that animal, and methods such as eat, sleep, make sound of animals in general. So when we are talking of a class, we are talking of a group of objects of the same type, of the same class. Just for example, just like the example I gave you before of the animal class, we've got in the animal class, we've got elephants, we've got pigs, we've got cats, we've got lions. Those are members of the animal class. Okay, let's move on to object. What is an object? An object is an instance of a class. Is a specific instance of a class. What does this mean? When we say an object is an instance of a class, as we said earlier, a class is a broad term that encompasses many objects. Like the animal class encompasses many or individual animals like elephant, lion, cattle, dog, just like that, and it goes on. So the real object, the member of a class, the real object is an elephant. That's an object. So we can say every animal has got an age, every animal has got weight, every animal has got a name. So those are the attributes of animals. So every member object of the class animal we will take those attributes. So when we are saying an object is an instance of a class, we are meaning that an object is the real thing that's inside that class. Another example for an object, maybe we can say alpha is an object member of people class. Okay, let's go on to attribute. What is an attribute? An attribute is a variable or a property that belongs to a class or an object, and it stores some information about it. For example, the attribute name of a class animal stores the name of each animal object. The attributes can either be instance attributes, which are unique to the object, or class attributes. shared by all objects of the same class. Before I proceed, if there is anyone with a question, please you can just say it so that we can clarify for some things which may not be clear when I explain. Okay, let's move on to another definition of a method. In object-oriented programming, we have some things that we call methods. A method is just a function, a procedure, or we can call it a behavior. Okay, before I proceed with methods, we can go to attributes. Attributes, sometimes we can call them the states. And sometimes you can hear the word state in object-oriented programming. The state normally refers to the attributes. And sometimes you may hear something like behavior. Behavior refers to a method. A method is a function or a procedure that belongs to a class or an object. For example, on our definition of a class, we mentioned something like animals, they eat, they walk, they make sounds. You know, those are some of the behaviors animals do. So that's what we call functions. Okay, as we all know that what functions do, like what we were doing earlier in other programming languages. There is also another thing that's called a constructor in object-oriented programming. A constructor is a special method that is used to create and initialize new objects of a class. A constructor is usually a retain with the same name as the class and is invoked with the keyword new. The purpose of a constructor is to initialize objects, to initialize attributes of an object, and to create also to initialize the what we call methods. That's a constructor. For example, you can use a constructor animal. Then you can pass the attributes name, age, and weight inside the parentheses to create a new animal object with a given name, age, and weight. We have also another thing that is called an instance. An instance is just a relationship between an object and its class. For example, a lion is an instance of animal, meaning that a lion is an object that belongs to a class animal. So that's an instance. I think now we are done with the definition of terms. We are moving to some examples of classes in real life. Here we've got an example of a car, of cars. We have other examples like people, animal, etc., etc. And the classes define a common attributes of actual object. For example, we have a car here. You can see that we have 3 cars here. The first one, he has got model, color, speed, has got doors. The second one has got the same attributes, model, color, speed, and doors, and as well as that third one. But they just differ in their color, they differ in their names, they differ in the speed limits. So that's how classes and objects are. We have a class called car, and the real object of that class car are the Mercedes-Benz car, which is red in color, which has a speed limit of 300 kilometers per hour, and it's got 3 doors. We have got that Honda Fit, which is blue in color and has a 200 kilometers per hour speed limit and 5 doors, as well as the Toyota Hilux with white, which is white in color and has 200 280 kilometers per hour speed, and it has got 2 doors. So these are the objects. They share the same attributes. These are the attributes here are model, color, speed, and doors. These are the attributes that we were talking of earlier. We define these attributes inside a class. Okay. Here we have an example of a car where we can define the attributes such as model, color, speed for cars in general, which means all the cars, they have this, I explained this earlier. And we can see that all cars disregard of the model, you have the same attributes: model, color, speed, and speed. This makes them the instances of a class car, which means Honda Fit is an instance of car class. I think I'm explaining something that is being understood. Am I? Hello, colleagues, are you there?
Yeah, we can understand you.
Okay. Thank you. Allow me to proceed. Is there anyone with a question? Okay. Allow me to proceed. Now we are going to define what are classes. What exactly are classes? In this part, we are going to look at how to create a class in Java using the class keyword and the class name. We are also going to explain the syntax and rules for naming classes in Java. We are also going to describe the structure of a class, including fields, methods, and constructors, as well as show in some examples on how to create a simple class in Java. So here we can see that to create a class in Java, we have got some steps that we have to follow. Number one, we use the keyword class to declare a class, followed by a name of a class, and the name should start with an uppercase. And we also have to, after the name, we open the curly braces to enclose the body of the class. Inside that, that's where we can define the fields and the methods of the class. The data fields are the attributes. So you may hear me using fields and attributes interchangeably, but they are just do mean the same. So here is an example of a class animal, which has got a name attribute and a method make sound. Okay, allow me to open this IDE. I'm using IntelliJ IDE. Here we've got a class called main and a method called main. So here we can create new class. Where is create new class now? Let's create new class now. Someone show me where there is a create new class. I think my IDE is playing games with me.
Is it not at the new keyword at the top? File new. And then
File new. Okay. Thank you. New Java class. Okay.
yes.
Then I provide a name here. I want to put animal. We said the class name should start with an uppercase letter. So we put in uppercase A, animal, and we press enter. And you can see that the ID automatically creates the class animal for us. So inside the class animal, that's where we can define the attributes. So we said in our example, in our slide there, we were talking about, we said that the animal can have age. So we all know that age is an integer data type. So we declare, we prefix the name of the attribute with a type int, and we have weight. Weight can be in decimals, so we can use double keyword to declare a weight. Sorry, there should be a semicolon here. You also have to note that, according to my research, I saw that it's a good practice to, when naming variables, a good practice to start with a lowercase. And you can note that all my variables here, I'm declaring them using starting with a lowercase for the first letter. The other attribute of animal is what other attribute we talked about? Sorry. Okay, we have a method called make sound. So we want to add that method as well. We want to add that method as well. Then we can say, so since this method is not returning anything, so we prefix it with a void keyword. So void make sound. Make sound. So this is how we declare methods and attributes inside the class. Okay, let's move forward. Also, to declare a class in Java, you need to use the class keyword followed by the name of the class and a pair of curly braces that enclose the body of the class. That's what we demonstrated earlier. The name of the class should start with an uppercase letter. This is a convention that helps to distinguish classes from other types of identifiers, such as variables and methods. For example, a class animal, we demonstrated this earlier. Also, the other practice we should note is that the name of the class should be a noun or a phrase that describes what the class represents or does. Let's take for example, we want to imitate something like as we said earlier, we gave examples of animal, cars, people. So that's a good practice. We should use those nouns to define what the class is all about. Also, the name of the class should be a noun. Oh, that's what I was talking about. And the noun should be a precise. It should not be that too long. Then the name of a class should not contain spaces or special characters such as the ampersand, $sign, commas, hyphens. It's not allowed, it's illegal. So these characters may cause errors or confusion when used in classes. For example, class animal and ampersand car is not a valid class name. It's illegal. Also, the name of the class should be short to the point, not longer than 30 characters. I think I said this earlier that the class name should not be too long. Long names may make the codes less readable and harder to type. For example, you can, for example, you say class animal car calculator is too long for, and it looks vague. Then also, if the name of the class consists multiple words, each word should start with an uppercase letter, which is called camel casing conversion. So, sorry, it's not camel casing, but it's called Pascal casing. Every word should begin with an uppercase letter, like as you see above there. Okay. As you see above the animal car calculator, on every beginning of the word, the letter is in uppercase. And this is called camel casing. It helps also to separate the words visually. For example, I gave the example earlier. And also the name of the class should use whole words and avoid acronyms and abbreviations, unless they are well known and widely used. For example, class URL is unacceptable, but class calc is, okay, sorry, the URL class is acceptable because we always use URL, it's widely known. But if you say class calc for calculator, it's not acceptable because someone might not know what you are trying to mean. Okay. Let's move to the next subtopic, which is the structure of a class. The class consists of the following components. The first component is the package statement. This is an optional statement that declares where the class belongs in the project hierarchy. Unfortunately, for now, I cannot demonstrate this because this is just an optional thing. You can decide to do it or not to do it, but it helps to avoid name conflicts and organize the classes in logical groups. For example, you can name your package like package .com example. Maybe it might be the name of that class. Also, it is important statements. We have important statements. These are optional statements that allow the class to use other classes from different packages or libraries. They make the code more readable and avoid typing the full name of the classes. For example, import java util.scanner. Allow the class to use the scanner class for the java util package. Also, we have comments. We can write all comments in our Java classes. These are also optional statements that provide additional information or explanation about the class and its components. They are ignored by the compiler and are only for human readers. And they can be either a single line comments, which are prefixed with double slash, or a multi-line comments where you start by a single slash and an asterisk, then in between you write your comment and you end with an asterisk and a slash again. So here is the example. You can visualize it here on the screen. Also, we have the class declaration. This is a mandatory statement that defines the name and the modifiers of the class. The modifiers can be either access modifiers, public, private, protected, or default, or non-access modifiers, final, abstract, static, etc. So you saw earlier when we demonstrated in the IDE, when we created the class animal, the IDE already prefixed our our class with the public keyword. This is called access modifier. I think this will be discussed later. The class declaration also specifies the superclass, if any. If it is a superclass, you define it on the class definition, and also the interfaces, if there are any, that the class extends or implements. The class declaration is the following syntax. So you start by the modifier, the access modifier. That's the public keyword or private keyword, protected or default keyword, or the non-access modifiers, which are final, abstract, static, just like that. Those are modifiers, followed by the class keyword. The class keyword is written in lower cases, class, then followed by a class name. Then after the class name, that's where when maybe the class is extending from a superclass, that's where you write the keyword extends, then you write the superclass name, or maybe the class may be implementing an interface, so you write the keyword implements, then the interface name. Or maybe it may be implementing the interface method, so you write those you prefix it with the implements keyword, then you write the interface method name. For example, the public class animal extends creature, implements movable, eatable, etc., etc. Then you open the curly braces. Inside the curly braces, that way you write the body of the function. And this one declares a public class named animal that inherits from a superclass called creature and implements two interfaces named movable and eatable. We have, after the class declaration, we have a class body. A class body, this is a mandatory block of code that contains the fields, methods, constructors, nested classes, interfaces of the class. It is enclosed by curly braces. For example, here we have inside the curly braces, we have int x, the declaration of that attribute, void display, the method, blah, 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 blah. So this is an example of a class body with one field and one method. Then also we have fields inside the class, and these are the variables that store the state or the data of the class or its objects. They can be either instance fields, unique to each object, or static fields shared by all objects of the same class. They can also have different access levels, public, private, protected, or default, and other modifiers, non-access modifiers, like final, static, volatile, and so on. They are declared by specifying their data type and the name. And optionally, assigning an initial value. For example, private, integer, age is equal to 10. This is a declaration of age field with which is of type integer with an initial value of 10. This is how we declare our fields. Then we've got also methods inside the class. We also declare what we call methods. As we said earlier, methods are just functions. They're just normal functions as we already know from other languages. And they are responsible for doing some actions and operations related to the class or its objects. They can be either instances or instance methods specific to each object, or static methods common to all objects of the same class. They can also have different access levels like public, private, protected, and so on. They are declared by specifying the return type. First, you have to state the return type of the method. Then you followed by you follow the name of the class. Then you open the parentheses. Inside the parentheses, that's where you provide the parameters of that method, and you open the curly braces. Inside the curly braces, that way you write the body of that method. Next, the other thing which is which we declare inside the class are constructors. So constructors these are special methods that are used to create and initialize new objects of a class. They have the name, they have the same name as the class, and they do not have return type. They can have different access levels: public, private, protected, or default, and the parameters, if any. They can also call other constructors using the keyword this for constructors in the same class. For example, we can say public animal, then we provide the parameter string name, then inside there we can also provide the value of the name which is in the parameter to the name variable inside that particular class using this word. Okay, I think we need to demonstrate something here. We need to demonstrate something here. I would like to continue with this example we started earlier of an animal class. Okay. Allow me to add some data fields here. We've got the age, name. I've got let me put name here. Name should be a string. It's a string data type. So we prefix it with a string. Sorry, the string should be in uppercase. String name. Something wrong here. String name. Okay. Then we would like also to provide something like this is just a state. We want to check whether this animal is a pet or not. So we say is pet. Then we would like to have a method. We would like to have a method. Allow me to remove this one. We'd like to have a method which is public. animal. This accepts this. This method has got 3 parameters. The name, the age, and the is pet variable. Boolean is pet, right? Accepts 3 parameters, and this method will be setting name. We'll be setting name for that particular object. We'll be setting name for the particular object, and also it will be setting age for the particular object. Age. Sorry, I should put a dot operator here. And as well as it should also initialize the that Boolean is pet. You have also note that after every statement we put a semicolon to terminate the statements. This is another rule in Java. If you can note that if we leave this statement like the declaration, the initialization of is pet variable, we can, if we leave it without the curly braces, it highlights as an error. So we have to terminate each and every statement. All right, let's proceed. I would like also to, we would like to have another method. Like to have another method, like this method will be also public, and will retain a string. So this name, this will be get name. String get name. This one doesn't need any parameters. So this will retain the name of that particular object. Okay. We need also to introduce another method which will retain which will retain which will decide if the animal, if the given animal is a pet or not. Okay, so it will be also, I'll just use public modifiers here. This one will be a Boolean function because it will retain a Boolean value. Let me call it get is pet. Get is pet. All right, this one also won't need any parameters, and it will retain, given the particular object, then it will retain whether it is pet or not. Then the next one, the last one will be get age. Get age function. It won't need any parameters as well. And sorry, I forgot to put the return type there. I'll put the return type. So return this dot h right. You can see that it's highlighting an error here because I forgot to put. I hope you are seeing my screen very well. Hello guys, can you confirm if you are seeing my screen very well?
Yes.
Let me allow it. Okay, thank you. We love it and you figure. Okay, these are the methods I wanted to introduce on this. So to make this program work, I would like to have the main method. Okay. This will be public. Let me just say greet. This will print the greetings message to a particular animal. Okay. So this this greet function will print something like okay, to print something on the screen, we use this system class. Inside that system class, there is a attribute called out. Inside there is a method called print line. Then print line, we pass a string inside the method. We pass whatever we want to print on the screen. Let's say the animal is introducing itself. Hello, I am. Then we would like to concatenate with the current object name. So we say this dot name. And inside this method, we would like to check if this animal is a pet or not. So let us use the if statement here. If
you've done this long time ago.
Sorry. Can you come again? I didn't. Okay, thank you. Just allow me to finish this one. I'm already done, so that I'll proceed. This, we want to check if this is pet. Then it will print say I am pet. Else system dot line. So we are done with this code now. We can create an instance now in the main class, in the main class and inside the main method now. We can create an instance of that animal class. We can call animal as a type. Then let's say cat. Then is equal to new. Now here we are using the constructor now. Let's go to new animal. Then we put the name of this animal. Maybe this cat is called Kitty. We also pass. We want also to pass something like this. This cat is a domestic animal, so it's a pet. Okay. Let me put age. Maybe it's 2 years old. Then its pet is true. So you can see that this is how you can create an instance in Java. I wanted to finish this code so that I'll run it, but since we are running out of time, allow me to continue. Maybe by chance we'll continue with the program. Now we want to look at our object creation. First, we will look at how to create objects. To create an object, first there should be a class that defines the attributes and methods of the objects. For example, let's say we have a class named person that has 2 fields, name and age, and the one method greet. So an object with the name Peter can be created using that class. Secondly, when creating an object, we use the new keyword and the constructor of the class to create a new object. I think I demonstrated it when I was writing a code. This is how we create an object. I created the cat object using the new keyword here and using the constructor animal, which I passed these parameters so that it will know that this cat is a domestic animal and has 2 years and its name is called Kitty. That's how we create an object. Number 3 on how to create an object, you can use the dot operator to access the fields and the methods of the object. The dot operator can connect the object name and the field or the method name. For example, let's say you want to print the name and age of Peter. So this is how you do it. You just. So now I want to demonstrate this. Since we have that class called animal. Inside that class called animal, we have a method. We have a method called greet. So we can call that method called greet here, so that and we use the dot operator to print out the details of that cat object. Next one, we put and the syntax and rules for naming objects in Java. Since objects are instances of classes that can be assigned to variables, here are some of the common conventions for naming objects in Java. First, the objects should start with a lowercase letter followed by an uppercase letter for each subsequent word, which is called the camel casing. And it helps to separate the word visually. For example, my car, student list, hello world, etc. Objects should be short and meaningful, not longer than 30 characters. Also, objects should use whole words and avoid acronyms and abbreviations unless they are well known and widely used. Objects should not contain spaces or special characters like ampersand, $, hyphen, underscores, and so on. Objects should not start with or contain digits such as 1, 2, 3, or etc., etc. This may cause errors and confusion. Now we want to look at when we declare and initialize objects, what happens in the memory and how does it allocate these objects in the memory. So allow me to start by defining what is memory allocation. This is a step where the Java virtual machine reserves the space in the heap memory for the new object. So allow me to go back a little bit. When we want to code in Java, in our machines, we should have what we call Java virtual machine. It comes up in a bundle of a package what's called a Java development kit. That Java development kit contains this Java virtual machine. And this Java virtual machine reserves some memory in the heap memory for the new object. I think we all understand when we say heap memory, we from the previous courses we did, we were learning about how these memories work in programming the heap and the stack. The heap memory is part of the RAM that is used to store dynamic data such as objects, arrays, and strings. Then the Java virtual machine uses garbage collector to manage the heap memory and reclaims the space occupied by used objects. Okay, unlike in C++, here the Java virtual machine deallocates the memory on its own when it's no longer needed. In C++, we used it to deallocate manually. Then initialization. This is the step where the Java virtual machine invokes the constructor of the class to initialize the same name as the class, and it takes some parameters to assign values to the fields. The constructor can also call other constructors using keywords. Using the keyword this for constructors in the same class, or constructors in the superclass. The constructor can also perform other operations such as creating other objects, calling methods, or throwing exceptions. To create an object of a class in Java, you need to use the new keyword and constructor of the class. For example, we have we are creating an instance of the class person called P, which we assign to P, and it's called John, with age 25. And this is what this statement will do. It will allocate some space in the heap memory for a new person object and invoke the constructor person string name and integer age to initialize the fields and methods of the new object. It will assign a reference to the new object to a variable named P. So the variable named P is the one which will be stored in the stack memory, but in the heap memory will be stored the actual object. That's how these things will happen in the memory context. You can then use the dot operator to access and modify the fields and the methods of the objects. For example, you can call p.name is equal to Jane. Then you have modified the name of that instance. You can also call you can call the greet method. Okay. For the sake of I would like just to demonstrate this. Like here, we created an object that kitty object. So we would like to call a greet function. We just use a dot operator. Dot greet. Right. My goodness. I think my code is some errors and it's not running. Okay, let me proceed. Right. We want to look at how do we create multiple objects of the same class in Java. One way of doing this is to use an array, which is a collection of variables of the same type. You can use, we can declare an array of class type and then create an object for each element of an array using the new operator. For example, you have a class called person with a constructor that takes a name as a parameter. You can create an array of person objects like this. Person, then you declare a person array, then provide a name for the array. In this case, is people, and a constructor, and provide the size of the array. Now you can create many objects of that same class. Now you say people at index 0 is Alice, people at index 1 is Shumirai, people at index until 4. That's how you create many multiple objects of the same class. Then when you want to print them out, you just call, maybe you want to get the name of the first person of Alice, you just print people at 0 dot get name using the dot operator. That's how you create multiple objects of the same class. Let's move on to accessing members of the class. Number one, how do we access the fields and methods of an object in Java using the dot operator. First, you need to have an object of a class that has some fields and methods. For example, let's say you have a class named person that has 2 fields, name and age, and 1 method, greet. You can create an object of this class by using the new keyword and the constructor of the class. For example, person P is called a new person, John, age 25. This creates an object of person class with the name John and age 25. Second, you need to use the dot operator to access the fields and methods of the object. The dot operator connects the object name and the field or the method name. For example, p.name accesses the name of the field of the p object, and p.greet accesses the greet method of the object p. Number 3, you can use the values of the field or the result of the method for different purposes, such as printing, assigning, comparing, and many more. For example, we have this example here. We have this example here where we are accessing the name of the P object. Then we are printing it to the screen. Name is called .p name. Is called p.name. Age is called p.age. Then we want to greet the P object. Then p.greet. That's how we do. That's how we do the operations. Now let's look at the concept of access modifiers and how they affect the visibility and accessibility of members of the class. What are access modifiers? Access modifiers are keywords that determine the visibility and accessibility of the members of the class, such as fields, methods, constructors, and nested classes. They are used to implement the principle of encapsulation, which is one of the fundamental concepts of object-oriented programming. Encapsulation means hiding the internal details of the class from outside the world and providing a public interface to interact with the class. In other ways, encapsulation is where we hide the implementation details. Or there are 4 main types of access modifiers, which are namely public, private, default, and protected. Public. The public modifiers makes the member accessible from anywhere, which means any class, any method, any attribute which is prefixed with the word public can be accessed anywhere in other classes, or even in other different packages of that same program. Then we have the private modifier. The private modifier makes the member accessible only within the same class. It has the narrowest scope among all modifiers, and it is used to hide the implementation details of class and to prevent unauthorized access of modification. So there are some things that happen during when the code is running. Maybe you may be assigning some data to some of your variables dynamically. So by means of using private keywords in some of your fields and classes, will prevent the program to have some unforeseen bugs and problems. We have the default modifier. The default modifier is also known as the package private. The default modifier makes the member accessible only within the same package. That's the difference with the private. The private is accessible within the same class, but the default, any class or object or a method prefixed with the default keyword is only accessible within the same package, and it is applied when no modifier is specified implicitly. We have also a protected modifier. The protected modifier makes the member accessible within the same package and also within the subclass in different packages. It is a narrower scope than public, but wider scope than default and private. So we can see that this one is available in the same package, but also can also be accessible in some in other subclasses of the different package. So that's the difference of protected with the private and default, while the public is available everywhere. I think we have reached to the end of this presentation. This is the summary. I'll just read through the summary. Number one, classes and objects allow us to implement the concept of object-oriented programming, which is a programming paradigm that relies on the idea of creating reusable and modular codes that can represent real-world entities and concepts. This is what I was trying to do on our code. Is you saw that I created a class called animal, and we code it in our main class. We can as well create as many classes as possible, and we use them in our main class. Number two, classes and objects enable us to create our own custom types, which can make our code more readable, maintainable, and consistent. Number three, classes and objects support the principle of abstraction, which means hiding the implementation details of object and only exposing its functionality. This makes the object easier to use and understand by other parts of the program, and also protects the object from unauthorized and unintended changes. Number four, classes and objects support the principle of encapsulation, which means bundling the data and the methods of an object together and restricting access to them from outside the object. Number five, classes and objects support the principle of inheritance, which means creating a new class from existing ones by inheriting their attributes and methods. Number six, classes and objects support the principle of polymorphism, which means having different objects respond differently to the same message or a method. This is what we demonstrated on creating multiple objects of the same class. We can have as many objects as possible in the same class, and they use the same methods, same attributes, but they do the different things. Here is the references where we were finding the information when we were doing our researches, and the group participants is. I think this is the end of our presentation, guys. Over to you, say, Mr. Chimana.
Okay, I just want to see if we've got some questions from the class. Do we have questions or contributions? What about on the group members? Do you want to contribute something? Add something? Where there is a hand by Thomas. You can unmute yourself and then you can contribute if it is a contribution, or you can ask if it is a question. You are not audible, Thomas. You are not audible. Maybe you can type on our chat. You are not audible. What about others? you have questions, something to contribute on the group members? Okay, it was just for thank what the group leader for good job. Okay, nice. What about future P? Do you have something to say?
No say.
Why not? Why not?
The research was good enough for me. I mean,
Okay. What about Munode? Munode? There is a hint by Saint. You can contribute if it is a contribution. Just unmute yourself.